Alright, so now we're on the bottom of page 4, and we're going to talk about the distance formula next, and then the midpoint formula. So, say you have 2 points, and you want to know the distance between the 2 points. That's what this next formula is going to give you. And then say you have 2 points, and you want to know where's the halfway point between those 2 points. That's the one on the next page that we'll cover. So here, the distance d between any 2 points, we'll call the first point x1, y1, and we'll call the second point x2, y2, is given by this formula. So d equals the square root of, we're going to have something squared plus something squared. And then what goes in these parentheses is x2 minus x1 and y2 minus y1. So you need to have this formula memorized. So let's use the formula. Find the distance between this point, -2, -3, and the point 4, -5. It doesn't matter which one you label x1, y1, and x2, y2. I could make this one x1, y1, this one x2, y2, or the other way around. It doesn't matter. So let's just call this one x1, y1, and let's call this one x2, y2. And so then if we want to find the distance, we put square root, parentheses squared plus parentheses squared. So we're supposed to, what the formula says is do x2 minus x1. So x2 is 4 minus, and then x1 is -2. So we have to put minus a -2 in there. Okay, so we have minus a negative. And then we do the same thing for the y's. We have to do y2, which is -5, minus y1, which is -3. So we have minus -3. And then the rest is simplification, work from the inside out. So 4 minus -2, that's 6. So we have 6 squared plus -5, and then we'll have plus 3 is -2. And that whole thing in parentheses, because we're squaring the entire number -2, and so we need the parentheses there. So, next, 6 squared is 36, -2 squared is 4, 36 plus 4 is 40. So if this were root 49, we'd say 7. If it were root 37, we would leave it as root 37 because you can't break it down, but this one is root 40, which we can break down because 40 is 4 times 10, and 4 is a perfect square. So root 4 is 2, and then for root 10, that is as far as we can go with that one. So the distance between those 2 points is 2 root 10. And then, but it doesn't really make sense, or it's not something that we would usually say is, oh, they're 2 root 10 units apart. So let's see on a calculator what 2 root 10 is. So 2 root 10 is 6.3. So D is approximately 6.3 units. That's the distance between the 2 points, is a little over 6 units apart. But since you don't have a calculator, this would be your in-class answer, and then this one might be a online homework answer, depending on how the homework asks you for the answer. So sometimes your homework might want a decimal, and so you'd maybe use a calculator to get that. But in general, you would just leave it like this. Leave it how you would if you didn't have a calculator to figure out what that decimal is. Alright, so that's the distance formula. And moving on to the top of page 5, Now we're going to talk about the midpoint formula. So this formula, you still start with 2 points, but this time instead of finding the distance between them, you're going to find where's the halfway point between them. So if the endpoints of a segment are x1, y1, and x2, y2, then the coordinates of the midpoint of that segment are, alright, so this time we have, since we're looking for one specific point, it's going to be some number, comma, some number. To get this number, you add the x's together and divide by 2. And to get this number, you add the y's together and divide by 2. And this makes sense that this should be the formula, because basically what we're doing is averaging the x values and then averaging the y values. So an average is a type of middle. So this is really is finding the middle of the 2 original points. So this example says, find the midpoint of the line segment whose endpoints are 0, -7, and 14, -4. And just like for the distance formula, it doesn't matter which one you label what. So just to show you, I'm going to label this one x2, y2 this time, and I'll label this one x1, y1. But it doesn't matter, we could have flipped them as well. So for the midpoint, we add the x's together, so x1, 14, plus x2, which is 0, divided by 2. And then we add the y's together, y1 is -4, plus y2 is -7. So we have to do -4 plus -7, and then divide by 2. And simplify, as always. So for the x coordinate, we have 14 over 2, which is 7. For the y coordinate, we have -4 plus -7, which is -11, over 2. And just leave it like that, leave it as a reduced fraction, and you're good. So this is saying, say, if you plotted this point, 0, -7, and then you plotted this point, 14, -4, and you found exactly the middle between those 2 points, it would be at this point, 7, -11 halves. So 7, -5.5. Alright, so those are the distance and the midpoint formulas. Now we're going to switch again, talk about circles. So one thing that we graphed specifically in this section were lines. So there was a special formula for lines, ax plus by equals c. Well, same thing for a circle. There's a specific form for the equation of a circle. So that's what we're going to talk about here. First, let's define what a circle is. So a circle is the set of all the points in a plane that are the same distance from a given point, and then that given point turns out to be the center of the circle. So what that's saying is, say you have a center, that's going to be the center of our circle. And then let's say that we want to find all the points that are this far away from this point. So we have that point, maybe this one is also that far away, maybe this one is. So far all these points are the same distance from that middle point. And then maybe so is this one, and so is this one, so is this one, so is this one, and so on. And when we find all those points that are the same distance away, that's what forms a circle. So the circle is this outside part. So I'll kind of go over the actual circle itself is here that I'm circling right now. The center is not actually on the circle, it's just the middle of the circle. Okay, and then this distance here has a special name. It starts with an R. This is our radius. And then if we went all the way across the circle to the other side, that would be called the diameter. Okay. All right, so now let's get into the equation of a circle. So this would be used to help graph the circle on a XY plane. The standard form of a circle, of the equation of a circle that has center HK and radius R is, so in parentheses, x minus h, and then that's in parentheses and squared, plus, in parentheses, y minus k squared. And that equals r squared. Okay, so x and y are variables. And then h, k, r are all specific numbers. Okay. Constants. And h, whatever h is and whatever k is, that gives us where the center of the circle is going to be. And then whatever this number r is, that's how long the radius of the circle is, this part here. Okay, so find an equation of the circle with a radius 2.5 and center -4, 6. Well, we know that the equation of a circle should look like this: x minus h squared plus y minus k squared equals r squared. So that's what you should write down first, just the skeleton of the formula. And then r should be 2.5, and since this is the center, that's what we call hk. So h is -4 and k is 6. So all we're going to do is substitute these numbers into this equation. X is a variable, so that's just going to stay x. X minus h. Well, h is -4, so we have to do x minus -4 and then square it. Plus y minus k is 6, so y minus 6 squared equals, and then the radius is 2.5, and we have to square that. And then let's just simplify a little bit. X minus -4 is x plus 4, and then square it, plus y minus 6 squared equals, and then 2.5 squared is fast to do by hand, so 5, 12, 0, 0, 5, 5, 2, 6. Okay, so we multiply that by hand. Sorry, I did it sloppy, but 2.5 squared turns out to be 6.25. And then that is the nice form of the equation of a circle that has center -4, 6, and then radius is the square root of this, which is 2.5. Let's move on to page 6. The top, actually the rest of this is still going to be on the circle material, but it's going to be a couple different examples. So first, find the equation of a circle that has center 4, 2 and is tangent to the x-axis. Alright, so we have to know what this word means, of course, before we could do this problem. Tangent means touches at one point. So this one might be better to draw a picture to get an idea of what we're looking for. So let's draw an XY axis. And it says that the center has to be at 4, 2. 1, 2, 3, 4. 1, 2. Draw in, write in my scale. So the center is supposed to be right 4 up 2. That's where my center is going to be. Now, of the circle. The other thing that we know is that the circle has to be tangent to the x-axis, meaning the circle has to touch the x-axis at one point. Well, if that's the center of the circle, then the circle would touch the x-axis right here. Right? Our circle would look something like that eventually. If it touches the x-axis at one point, it's going to touch there. Well, that gives us some insight about the radius. Since the center is HK, the only thing we need to know is what's the radius. Once we have HK and R, then we can use that formula again. Well, if this is the center and this is a point on the circle, what's the radius? This would be the radius, and that's going to be too long. So the radius is 2. So now we have this information and we have this information. Now we can just plug it into this formula for a circle. X minus h quantity squared plus y minus k quantity squared has to equal the radius squared. And then let's just plug in h, k, and r. So x minus h is 4 squared plus y minus k is 2 squared equals the radius squared. And then the only thing really that we have to simplify is this 2 squared, which of course is 4. And so now that's the equation of a circle that has center 4, 2, and is tangent to the x-axis. So really our circle is eventually going to look something like that. And let's do one more. We're going to graph a circle. We're going to graph the circle x minus 5 squared plus y plus 3 squared equals 16. So what we need to do is identify what h, k, and r are going to be. We want, because this will give us where the center is and this will give us the radius, then we can graph the circle. So I'm just going to write the equation down again, and then I'm going to write what we know the general form of a circle is supposed to be. All right, and then compare these two formulas. So what should h equal? Well, h is here. It's always supposed to be x minus whatever h is, and here we have x minus 5. So h is 5. K, similar idea. We have to have y minus whatever k is, but here we have plus. So y plus 3 is the same thing as saying y minus a negative 3. So really, k is negative 3. So the center of our circle is 5, negative 3. And then we need to find r as well. But we know right now, just from looking at this, that the r squared is 16. Right, so I'm going to write r squared equals 16. Well, if r squared equals 16, that must mean that r equals what? It's equal to 4, because we're going to have to take the square root of both sides. And so really, if we're doing this full out, we'd get that r equals plus and minus root 16. So r equals plus and minus 4. But we know that it's r is representing the radius of the circle, so it has to be positive. Okay, so we have our center here, and our radius is 4. Sorry, it would kind of go more this order. I kind of skipped some steps, but so we'd go here and this way to finally get r equals 4. And then let's label x and y. put in my scale, I'm going to go by ones. 1, 2, 3, 4, 5. So I know that my center needs to be at 5, -3. And I'm going to do my center in a different color because that's not actually part of the circle. That's just where the middle would be. So that's our center. And then the radius has to be 4. So from the center, I'd go up 4. I'd go left 4. I'd go down 4. And I'd go right 4. I have to estimate where that is. And then just try to draw the circle in as best you can. Okay, it's not perfect, but that's the general idea. The important part is that we have the correct center, the correct radius, and some points.